Python Interoperability Productions aim to enable Python users to write interoperability productions purely in Python and without any knowledge of ObjectScript. This project also is useful for ObjectScript developers who would want to use Python in their workflows. To understand how a Python developer would access the productions architecture, it is important to go over some key aspects of a production that they would need to interact with. So we will first go over these, and then we will also directly go over some of the Python code and see how it fits with the architecture. This image from the Learning Services team nicely captures most of the key elements that any developer needs to know while designing their own productions. The message passing and persisting engine looks for certain callbacks in each business host. For instance, the onProcess input method for a business service. The engine also expects a certain order and number of arguments for these callbacks. Each host then uses some other key production methods like the send request async or the send request sync to communicate with other hosts. The engine also looks for us to persist this information being passed through the system and expects these messages to be persistable. The users would import the supporting code from the production connector and use it to create subclasses for the hosts that they will be creating. Once the user have written their code, they will use a parser to parse it and generate the links that link their code to the IRIS backend. This is a sample for how a persistible message would be defined in the user's code. They would just need to subclass from the production message superclass, and then they can define their fields normally. They could also define if they want one of these fields to be a new column in the storage table, or if they want indexing on any of the fields. This is how a sample business host would look like. In this, we are using the IRIS property and the IRIS parameter that has been imported again from the production connector to link the user's code to the UI. As you can see here, the target config name is something that a user would enter in the UI at the time of creating the production, and this will allow us to create an instance from this class. And the adapter signifies the inbound adapter that this business service class is using. This is how an entire production would look like. This is a working example. So from the left to right, as you can see, from the production connector class, you would import all the objects that you would need to create your production, like the properties, parameters, services. And then you would ideally create, as you can see on line 26, a data object, which is a persistible object. And then all the classes that you need can be on this one same file, or they can be spread across different files. In line 19, you see I've given a package name. So if you're writing your production across different scripts, you can link them to the same package by using this variable. This variable can also be overwritten at the level of each single class. The user can also import the debug method from the production connector, which essentially uses the debug.py module for step-through debugging of this code. In this flow, you can see the user creates a persistible object. The business service uses this and then passes it on to the process, which passes it on to the operation, and then a response is sent back all the way to the service. This is how a debugging workflow would normally look like. On the left, you can see I'm connecting to a VS Code debug.py instance, and I start the debugger in VS Code. And then I go and start my production. In the production, I have these debug host method calls, which link to the debug.py instances running in VS Code itself. As I step through the code, you can see the message is passing from a service to a process. Now, if I go to the UI and I see a message would have been delivered from the service to the process. This message is still not completed because it's on its route to the operation and the response has not been received back at the service. As you see that now I'm stepping through the code again, the message has further progressed in its journey. And now when I finally step through the code more, you can see that the message will, a response would finally be received at the service. And then you can, I have some logger modules with which you can log any information that you might want. And this is how a message is displayed in its JSON format. So essentially, the usage is that the user writes their Python script by importing from a production connector, and then the user runs this parser on that script, which creates links automatically in the IRIS instance. And then the user goes to the productions configuration page to create their own production, where they can click on the plus sign next to a service, process, or operation, and then just select these classes from the drop-down. There are some other things that we intend to add to this infrastructure, where the ability to create productions programmatically, where the user can write it in JSON, XML, or YAML. Right now, I'm just using the UI. We can also allow the users to write their own serializers. So for persistence, we need the messages to be serializable. And right now, we have JSON serialization. So your data classes would need to be JSON serializable, but in case a user would want something different, we can expose that ability for them to write their own serialization method in the message class. And also the ability to have their own display formats for the messages in the UI. Thank you.